Assalamualaikum warahmatullahi wabarakatuh. We are from Group 5. We are going to present about the Renewable Energy Control System, Pump Storage Hydropower PSH. So what is PSH? PSH is known as Hydroelectric Energy Storage. It consists of two large water reservoirs at a different height from each other. The concept and function of this PSH is to store the electrical energy in terms of gravitational potential energy of water in a big scale. So I'm going to explain briefly the mechanism of PSH. PSH will store water during periods of low demand and will use it back during the peak times. During the peak times, the water stored from upper reservoirs will be released back to produce the electric power through the turbines.
My part is about objective of this project. As we know, PSH or Pump Storing Hydroelectricity is a mechanism of utilizing excess power created by renewable energy source and it's consuming that energy during peak demand. Hence, eliminating emission which will produced by power plant that run on fossil fuel during the peak demand. So that is our objective for this control system project.
Next, I'm going to explain about the problem statement. So, the renewable energy sources such as solar panels and wind turbines is known as unreliable energy sources. That means they will produce maximum power when demand for electricity is low. So the power grids in most nations are designed to provide power at the time they are created. So as a result, the power plants must operate at a reduced capacity in order to maintain the load balance. Thus, more fossil fuel power plants must be added to the grid to fulfill this rising demand. So, this method is not only costly, but it is also incredibly harmful to the environment because almost 1/3 of all CO2 emissions will be released worldwide. Therefore, it is very reasonable to discover another way.
So for the problem statement, we can conclude the pump storage hydroelectricity is the most perfect solution to this problem because PSH allow us to use the excess electricity generated at noon to pump water from the lower reservoir to the upper reservoir, and it allowing us to reduce our carbon footprint. So that's all the problem statement from my group. Next week we'll continue to the methodology.
The methodology, a PSH, which is our pumped storage hydropower system, will basically have two reservoirs, while the first one is located lower and the second one located upper. And the upper and lower reservoir are shown in this diagram, as you can see. So the power plant chamber that is connected to the grid is also included, as you can see in the picture below. And so how this works is basically when the demand for electricity is lower than the supply, where you are needing more electricity than you already have, or than the one you get. So the turbine will pump water from the lower reservoir to the upper reservoir, storing electrical energy in terms of potential energy. Then later, when needed, the potential energy will again be converted into electrical energy and can be used to get or to obtain more electricity. This is usually done at night, during the off-peak hours. So as you can see, these are two types of pumped storage hydropower system. The first one is the open-looped pump storage hydropower, and the second one is the closed-loop pumped storage hydropower system. So the first one is called open loop because there is a continuous flow of natural water, while the second one is called closed loop because there is no continuous flow of natural water, as you can see from the picture. Next, turbine selection is one of the most important criteria for our PSH. So the one we chose is the Francis turbine. As you can see here, there are more types of turbine, but the one we considered were these 6, and we came to a decision that we have to choose the Francis turbine because it suits our PSH the best. Even though some of these turbines have more efficiencies than the Francis turbine, we still opted to use the Francis turbine because of the design and also the size. The Pelton and the Kaplan turbine have way more efficiency, but their size is just way too big for PSH. So this is a graph between the comparison of the efficiencies of the different turbines. As you can see from the graph, the Kaplan turbine has way more efficiency than the Francis turbine that we chose, but due to some issues with the design and also the size of the Kaplan turbine, we thought of choosing Francis turbine, which fits the best to our PSH. So last but not least, the block diagram. As you can see, there is a solar panel and a wind turbine or hydroelectric dam. So when the pump storage hydroelectricity, our PSH, or pump storage hydropower, electricity is generated from the renewable energy sources and undergoes DC or the AC inverter, which makes it more efficient to transport the electricity. Then it goes through the controller unit, and based on power demand, the controller unit decides either to give power to the turbine to pump the water uphill or lower hill by running the water from the upper reservoir to the lower reservoir. Then finally, from the controller unit again, the electricity goes to end to be consumed or to be used by the consumers. So that is all from me for today, and thank you.
Now I will be continuing for the discussion. So I'll be discuss about the advantages and disadvantages of pump storage hydroelectricity. So the advantages of it is it has long service time and minimal losses, and it has high efficiency. The storage capacity is large, and it brings minimal impact on environment and no emission of carbon dioxide. So the disadvantages are it requires the specific geographical situation, and it is expensive and hard to build, and it requires high amount of initial investment, and the energy density generated is low. So the conclusion of this case study is that the global energy consumption increased due to growing urban population and industrialization. So there are 78 fossil fuels is used to generate for the energy we use in our life, and there are only 19% of renewable sources we use during our daily life or in our daily life to generate to use the energy is only 19%. So most of the renewable energy sources is very unpredictable. So through this case study, we can know that the pumped storage hydroelectric can solve the problem. So problem is that it can store energy during the high output, and it can utilize the energy during the peak times, and it has long life cycle is around 75 to 80 years. And that's all from us. Thank you.